Hello and welcome to the Henstitute. In this one, we're going to talk a little bit about what happens when waves interact with each other. In other words, if I have a couple of waves that are traveling through a slinky or a spring, or they could be traveling through the air with sound waves, or you could have light traveling through some material because light is a wave or has wave properties. What exactly happens? Well, the main idea is you have what's called the principle of linear superposition. So I didn't put the linear on here. Let's put the linear on here. And so the idea is when two or more waves are present or simultaneously interact at the same place, the resultant displacement is the sum of the disturbances from the individual waves. So the resultant disturbance is the sum. So if I have, say, two waves here that are moving toward each other, and I've done transverse waves here, I'm going to come over to my little picture. So I've got one wave is traveling in this direction, one wave is traveling in this direction. So these are both, I've got two crests that are heading toward each other. And so this is where they're about to happen. When they actually overlap with each other, the slinky would have twice the height of either one of the pulses because of this principle of linear superposition. The resultant disturbance is the sum of those two. So this is then afterwards, the two waves will just continue on as if the other one wasn't even there. So they only interact while they're in the same position, and that's what's actually going to create it. This is what is known as constructive interference. And this constructive interference is when you build up to a larger wave. Well, that's great, but what happens if you don't actually have the two waves building up on each other? So I'm going to see if I can switch my picture here while we're still kind of covering everything. Now in this particular case, if you notice, I have two waves that are still heading toward each other, but this time, this wave is underneath, so it's a trough of the wave, and this one is a crest. But the two waves are still heading toward each other. So I've got a picture of this wave, and this wave is heading toward each other. This is no longer constructive interference. Instead, these two waves are actually going to still create a sum here. So I'm going to still write this as a sum, sorry. Didn't mean to erase that. But since they're in opposite directions, it's almost like they cancel each other. And so the resultant you get is this overlap where one of them would technically, we've got this one would be up a certain amount and this one would be down a certain amount, but they're actually canceling each other, or the sum is still there. But if they're in opposite directions, a crest and a trough, you're going to get what we refer to as destructive interference. Destructive. And so it's still a sum, but they can cancel if opposite of each other, just like they are going to add or increase if same direction. So that's what we're dealing with. And then the main idea is then after this kind of constructive or destructive interference, the two waves are still moving afterwards. So the key idea also is this principle of linear superposition. It only happens when the two waves are overlapping with each other. Afterwards, the waves actually travel right through each other like they're not even there. I'm going to see if I can try this out with an actual video of some slinky and maybe do some slow motion so you can kind of see this. Now, I like this picture for destructive interference, but one of the things I want to point out is destructive doesn't mean it always has to completely cancel. It just means that you're actually getting something smaller. So let's say that this crest was larger than this trough was. What you would actually get is right as they meet, you would get this little bump that would be kind of the combination. So this one's trying to pull it up and this one's trying to pull it down, but you get the difference between them. So this canceling might not be the best word, but you might actually get like a subtraction if opposite of each other, just like you get addition if they're in the same. So that's what we're dealing with our interference of waves and our what happens when waves overlap with each other. We're going to be using this as we get into a concept known as resonance a little bit later. Hope you enjoyed this edition of the Henstitute.